Hi everyone, welcome to the Alteon NG Fastview and APM demo. Managing the performance of an application and of the network is normally a task of the IT group, whether it's the network administrator or the application admin. But how can you manage what you can't measure? In this demo, I will introduce a couple of tools for managing the performance of web applications: Radware's Application Performance Monitoring, APM, and the Fastview Web Performance Optimization solution. It's a combination of tools which provide IT administrators with the power to manage the performance of their applications like no other solution in the market. Let's see how. This demo is built on a real-life production environment, the Radware.com public website. While this website already utilizes Fastview and APM, for our purposes, we will build a demo setup on a side branch which bypasses the production path and accesses the Radware.com server directly. To build the demo setup, we provisioned a new virtual ADC that includes both Fastview and APM. The Fastview machine with the embedded APM will send its data to the existing reporting engine already in use by the production Radware.com site. To generate traffic for the demo setup, I have configured my own PC, changing its host file so that when browsing the Radware.com website, my requests and responses will be directed through our demo setup. In addition, I will also access the APM reporting tool in order to monitor the SLA of the provided demo setup. In the first part of the demo, I will generate 10 different sessions, each one generating 3 different transactions, visiting 3 different pages on the Radware.com site. First, I will run through the sessions and transactions with Fastview acceleration turned off to see how the site performs natively and review the results through the APM tool. At Radware, we decided that our website SLA needs to meet a 2-second response time within the data center and an overall 4-second response time for the end customer. Afterwards, we will activate Fastview and run the same 3 transactions through the same 10 different sessions with the acceleration turned on, and then review the performance results again with our APM. So let's start with the Radware homepage on 10 different tabs representing the 10 different sessions. On each of the session tabs, let's go to the solution page, followed by the product page, and thus generating the 3 transactions on the 10 different sessions. Once all the transactions are complete, we will review the performance measurements on the APM reporting tool. To see those, we'll need to log into the reporting server. This will take us to the main dashboard, which summarizes all the relevant information on one screen. The first view is of the data center performance. You can see the accumulated statistics on the 30 transactions. We can see the amount of transactions, most colored in green, meaning they have met the data center SLA of less than 2 seconds response time. The upper graph shows clearly how the data center response time is actually measured much below 1 second. However, when moving to the end user view, we see that most transactions are colored in red, meaning the SLA the end user experienced wasn't met and exceeded our target of 4-second response time. In real life, this is something you would like to investigate more, so let's dive in and see more details on the SLA. The first view is the application view, a holistic view of all applications being monitored by the APM reporting tool. Here you can see both the overall public Radware SLA, where 90% of the transactions are within their designated SLA, while our demo setup has only 5% of its transactions meeting their SLA. The reason, by the way, is simple. Our public Radware.com site is already using Fastview, while at this stage of the demo, Fastview is still turned off and not in use. Moving to the transaction view, we can see that all of the transactions we have just performed are within the SLA. All transactions responding in less than 1 second within the data center. But this is the data center view, before it goes through the internet to the end user. When switching to the end user view, the picture changes completely. As you can see on the screen, less than 10% of the transactions are within the SLA, and the average page load time is between 6 and almost 15 seconds of delay, not even close to the 4 seconds delay we have set as our SLA. Clearly, we need to address our poor end user response times. So let's activate Fastview. This is the Fastview dashboard. In the acceleration page, we choose the Radware.com service, where we have already pre-configured the IP address of its servers. To activate the acceleration, we choose the treatment set we want to apply on the Radware.com site, and we press Save to apply the changes to the configuration. Basically, that's it. Nothing else is required to benefit from Fastview's acceleration capabilities. The first one is predictive browser caching. Using the browser's cache to store the objects needed for the next page that the user is most likely to visit. We can limit the number of possible next pages, in this case 5, and choose which types of objects, images, JavaScript, or CSS, will be sent. Another acceleration treatment is consolidation. Here we enable CSS consolidation as well as JavaScript and image consolidation. Next we have progressive image rendering, where we initially send a low-resolution image to allow the browser to become active faster, and only after we load all important objects in the page will we load the full-resolution image, while the user is already busy with the page. This can be of benefit in pages with heavy images. Now let's run the same 3 transactions again through the same 10 different sessions and see the performance difference when Fastview is active. In the main dashboard, we can see both transactions batched together. One before we activated Fastview and the second with Fastview activated. While in the first batch we can see in the middle bar that most transactions are colored in red, meaning they were out of the SLA. In the second batch, you can see that most transactions are actually colored in green, meaning they were within the SLA. In the top graph, you can see the average response time. While in the first graph, it was over 12 seconds. In the second batch, it was around 3 seconds. Going into more detailed view, in the transaction view, we can see how each of the transactions' average response time was between 3 to 3.5 seconds, and how 80 to 100% of the measured transactions met our 4-second end-user response time SLA. Going into even more detail, we can see a list of each and every separate transaction. You can see how the response time was between 5 and 2.5 seconds with Fastview per each single transaction, and in the comparison, you can see how the page load time was between almost 16 and 5 seconds, clearly much slower without Fastview. In summary, we have demonstrated the combined value of APM and Fastview, where APM enables us to identify performance bottlenecks on our website, and Fastview enables us to instantly correct them, all in an effortless way, using a very simple to deploy solution in Alteon NG with integrated APM and Fastview. When we do a customer POC, it will be conducted in exactly the same way, connected to the production environment, but through a parallel path. Initially, only the designated users go through the test POC setup, and later on, when the customer confirms the POC is working as expected, we can direct all or just a portion of the live traffic through the POC setup and accelerate it with Fastview. Moving to the second part of the demo, I would like to show how the APM tool can be used to debug applications that exceed the SLA. However, to make things more realistic, let's add another user in a different location, so that now we'll have one internal user in Tel Aviv and another one in our China office. Now let's see one transaction through 10 different sessions from each of those locations. Looking at the APM dashboard, we can see we have a problem, but it's not as clear as before. Only part of the transactions are outside the SLA, 43% of them in the product page and 25% in the home page. Using the same view, we can break down the report per area. So let's see the SLA report for only the transactions originating from the China office. Now it becomes clearer. 80% of the product pages are outside the SLA with an average response time of over 6 seconds. Looking at only the internal users, in our Tel Aviv case, we can see that 81% of the product page views were within the SLA and 100% of the home page views were within the SLA. This probably means we specifically have a problem only in the China region. Another view that can lead us to even more easily come to the same conclusion is the SLA report per location. Here we see that 82% of the transactions from the China office are outside the SLA, too slow, while 84% of the transactions of the internal users meet the SLA. So clearly we have a problem only in one region. One common real-life example for this report is to monitor your CDN provider's performance for different regions. For example, comparing the response time for German versus Chinese users. We can also view traffic volume data to determine how busy each region is. This can help us understand if we need to invest more or less in a CDN service for a given region. Imagine how much effort you would have to put in to gather all this information without Radware APM. Here, all you needed to do was turn on the APM function in the Alteon or Fastview, and you're done. Did I mention it's simple? Thank you for watching the Alteon NG with Fastview and APM demo. Happy accelerating and monitoring!